developed strategies in order to grow up 8 key competencies in young students. So all the school system was involved in this reform. I think that you already know these 8 key competencies listed by the European Union. They are all transversal competencies, so it means that they are not linked to single disciplines, but they involve all the disciplines taught at school. What was the answer of Italy to this new scenario? The answer was positive, because the concept of competence entered in school already in 2000, and in 2007 new guidelines were introduced in the school system in order to develop competencies. But the most important documents were produced by the Ministry of Education in 2012, and it's the new national guidelines. In this document, the 8 key competences, it is referred to the first cycle of education, I mean primary and lower secondary school. In this document, the 8 key competencies are clearly expressed and as a reference horizon to work towards. In the same document, there is also a general goal, the competence profile of a student at the end of the first cycle of education. And there are also the different objectives of the different disciplines. In particular, in the case of sciences, the goals for students are globally expressed for chemistry, physics, biology, astronomy, and earth sciences, because they are taught all together under the name of sciences. I don't want to read all the goals, but only to focus your attention on a few important keywords. Explores and experiments in the laboratory and outdoors, not only at school. Develop simple schematization and modeling. Macroscopic and microscopic level chemistry. Awareness, curiosity, interest. After the Ministry of Education conformed also the upper secondary school to these new guidelines, and now we are talking about new lyceum, new technical institutes, and new professional institutes. But in this new scenario, teachers had to change their way of teaching and to abandon all the transmissive method in order to focus on the actioning situation of the students. So actually the keywords are design, formulate curricula, and certificate competence. Of course, this is a joke, we know what to do, but it's very hard. And currently, teachers are looking for new successful experiences that can help them in their hard work. Moreover, in this new school, the Ministry of Education is also encouraging to use digital resources in the teaching of disciplines, not only in informatics, but in the teaching of all disciplines, with the aim of developing a transversal competence, the digital competence. And in this case, there are many problems. One of these problems is that many teachers claim low affinity toward ICTs. And also a little warning. In order to use digital tools as successful experiences, it is necessary to design. And while designing, it is necessary to take in consideration the interaction between the teacher and the students, and among students. and also to foresee practical experiences, because okay, virtual experience, ICTs are okay, but the practical experience cannot miss. So, as a first step, it is necessary to break down the distrust of teachers by encouraging them to use simple digital tools and to show a way to use them in a significant way. So we choose Tavola Periodica Pointed, that is a very simple site but does not require digital competencies, and it is rich of pictures and videos, so rich of hints for discussions. We hope that in this way teachers could have an example of how a digital resource, even if very simple, can be used to enhance learning of chemistry contents. For this aim, we proposed we proposed 2 hours of non-traditional lesson to 8 classes of upper secondary school. I told that it has been a non-traditional lesson because the virtual laboratory was joined to practice, to observation, to guided discussion, in order to connect previous knowledge to the new context. Of course, I cannot repeat in this context the 2 hours of lesson, but I can show you a few moments of the lesson. For example, in this slide, you can see a video, a picture, of the reaction between potassium and water. The site is rich of videos like this, and also of videos of dangerous reactions that cannot be repeated in the classroom or in the laboratory. So we use the site to watch the video of this reaction. Then the students were guided through discussion in order to build the equation of a chemical reaction, based on their observations and on their previous scientific knowledge. What did you see? Which are reactants, products, what is burning? This is another moment of activity, practical activity and virtual activity, side by side. At first we showed students the reaction of, between a piece of zinc and a solution of copper sulfate. And even in this case, a discussion was performed in order to build the equation of the chemical reaction, also basing on the change of color of a piece of zinc. Then the site was used to show a similar but much slower reaction. In this case, the copper sulfate reacted with anneal of iron. In this case, the virtual activity was useful because this reaction is very, very slow. Here, when we talked about the group of carbon, we watched the video of the burning of carbon, and it was an occasion to discuss about the burning reaction, to discuss about fuels and about the allotropes of carbon. But we also did a practical activity in order to show an application, a very diffuse application of carbon, the charcoal. And the well-known bleaching properties of charcoal. So we prepared a solution, a green solution, by mixing water and a food dye, green dye for food, and we filtered the green solution through charcoal. of course, we obtained a non-colored solution. And this activity was important because it linked the theory, the chemistry contents with everyday life, because charcoal is widely diffused in filters, filters for pools, for cars, for drinkable water, and it is sold in pharmacies for air in the stomach, you know.
Not only stomach.
Here we proposed a sort of didactic game. We gave students different samples of elements and objects, and they were asked to recognize them, to identify them, referring to their personal experience, but also referring to the information contained on the site. And this game was enjoying, of course, but also very useful. Finally, the video showing the combustion, the burning of the dangerous white phosphorus was a good occasion to discuss about a set application of chemistry, the chemical weapons. And it was an occasion to talk about the problem of ethics in science and in technology. Then we also talked about phosphorus and match and the invention of matches. In few words, we did an activity designed aiming to competence development. In this case, the active role of students was stimulated as much as possible through virtual activity, practical activity, guided discussions, challenges, scientific challenges to students. And the structure of this lesson was not the same for the 8 classes. It was slightly modulated as function of the answer of the students and of their scientific knowledge. The experience was appreciated, I think so, by teachers and students, but it was also assessed, investigating students' opinion, investigating teachers' opinion, but I won't show the results of this survey because they will be the content, the subject of the next presentation. The next presentation will be made by Andrea Traverso, that is a researcher at the Department of Education, and he collaborated with us in this activity. So you can go on.
I did this, I did that,